For this project, design analysis has been conducted in regards to product longevity for a bolted joist within a large crane structure. From the data recorded and the atmospheric conditions provided via the client, we base this analysis on the fact that our attachment system is located in Midtown Atlanta within a tower crane truss system. Given the high wind forces our attachment experiences, we assume it to be high above ground level. The attachment system we're concerned with is that of a bolt compressing two steel plate members together. In this analysis, we are focused on the bolt and the improvements to be made so that the life expectancy is extended and the deformation it undergoes to be reduced. To achieve this, a focus has been put on three main areas. The bolt's structural, thermal, and corrosion properties were targeted as improving weaknesses in these areas will yield the best results for what we are trying to achieve. We begin by evaluating the context of our system. Our attachment system is considered to be static, with preload acting on the bolt and a fluctuating axial load applied, causing a stretching of the bolt. We don't consider friction to be played for this situation. We are given the full magnitude of the applied load, with which we calculate the preload of the bolt and subsequently the maximum load the bolt will experience. From this maximum load, we can then go on to find the deformation caused by it. We then analyze the deformation that comes from thermal effects on the material, given the context of its environment and the material properties. It is important at this stage that we consider the effects felt outside of a closed environment, as many different factors contribute to the bolt's endurance limit besides just the forces. From here, we find how many load cycles a bolt will endure given the stresses it experiences. As a side note, it is very important when going through this process to consider what kind of impact a failure can have. We are dealing with a critical piece of equipment, one which could have devastating consequences given a failure of any sort. In that, we must also adhere to standards created by presiding agencies that set rules for these types of analyses. It is important to note machine learning can also be an invaluable resource when it comes to these sorts of analyses, as it can greatly increase our efficiency as engineers through being able to perform the same calculations with greater precision, given a project that adheres to more limiting factors. The first improvement we seek to implement is to increase the bolt's diameter from 1/2 inch to 3/4 inch. By doing so, we look to increase the strength qualities while also staying within our given parameters. By doing this, we find the bolt is to be subjected to a greater overall load through an increase in preload. In having this increase in preload, the calculations indicate that the stiffness of the bolt will also increase, which will in turn contributes to minimizing deformation by approximately 46%. We then evaluate what impact this will have on product life. Taking into account factors that impact it, we consider our endurance limit of the bolt and how it relates to our newly calculated reverse stress. Plugging this in shows that we're now within what is considered high life cycle range. For our thermal improvement, we've elected to stay with a steel-based bolt, but given research that shows that iron and nickel intensive steels experience less thermal deformation, we've elected to change the chemical composition of this particular bolt. In doing so, it yields an over 76% increase in the thermal deformation resistance. For our corrosion-based improvement, we figure the addition of lead-based paint that provides coverage for the entire attachment will provide a sizable impact in prolonging the life of our bolt. By hindering the oxidation process as well as the interior current flow, this method is not only cost-effective, but will also be easy to implement. Through this analysis and the results it has produced, it is believed that a sizable improvement has been made to the bolt in question. Our methods are within a reasonable cost range, adhere to the standards set forth by authorities, and can be easily sourced within the industry. Thank you for your time.